Confluence line is the effect of moving load on a bridge. So if you have a bridge like this beam, we have reaction at the support and another reaction here. Actually, the value of this reaction isn't one value because your load is a moving load. So we need to draw a diagram called influence line. So we need to draw influence line for reaction. We need to draw influence line for shear, influence line for moment. Actually, this topic for beams and trusses. But in this course, we will cover only beams. We have different type of trucks, cars, vehicles. So which car or which vehicle I will use? Actually, we will assume all of these types as unit load. We have only unit load, 1 pound, 1 kilonewton, whatever, 1 ton, it's unit load. So we need to draw the effect of this unit load. Then we can convert this effect to any type of these trucks. Okay? We learned before how to sketch influence line for reactions. Just a quick review. We have simply supported beam. So at A, we have reaction YA. At B, we have reaction YB. If you would like to draw influence line for reaction YA, push your support A up by 1. Any other support in your beam, keep it as it is, no movement. So the new shape of your beam looks like this. And this shape is positive. And this diagram can be called influence line for reaction YE. One more time, if you would like to draw influence line for YB, push your support B up by 1. Any other support in your beam, keep it as it is, no movement. The new shape of your beam looks like this. This diagram is positive, can be called influence line for reaction YB. You have cantilever. If you don't have cantilever, I don't care. But keep in your mind, very important note. This beam is 1 unit. What do you mean by 1 unit? 1 unit means the beam must remain aligned. This one is 1 unit. 1 unit means this beam must remain aligned. So if you are looking to draw influence line for this reaction YA, for example, so I will push this support up by 1. Any other support as it is. The new shape of your beam will remain aligned. So the new shape of your beam, something looks like this. 1 line. So this diagram can be called positive, can be called influence line for reaction YA. If you would like to draw influence line for this reaction B, YB, push your support up by 1. Any other support, keep it as it is, no movement, and put in your mind, this beam is 1 unit, 1 line. So the new shape of your beam looks like this. This diagram will be positive here. This diagram will be negative here. This shape can be called influence line for reaction YB. This is the case if you have simply supported beam between hinge and roller. If we have a case of fixed support, So at fixed, we have vertical reaction YA. We have concentrated moment MA. Remember, we already at fixed, we have horizontal reaction, but we don't care about horizontal reaction, any horizontal reaction in beams in the case of influence line, because your vehicle weight is vertical. And one more thing, your moment will be assumed MA to make your member to smile. Push your support up by 1. If you push this fixed up by 1, the whole beam will move up by 1. So the new shape of this beam, something looks like this, positive. So this shape can be called the influence line for YA. If you would like to draw influence line for moment at A, go ahead and rotate this fixed by theta equal 1. Remember, the original shape of this fixed looks like this. Here is a fixed, and here is the beam. Beam and this fixed, we have perpendicular angle. We have a 90-degree angle. So this angle must remain 90. After you rotate this fixed, the new shape of this beam must be like this, to be perpendicular to the new position of the fixed after rotation. This shape can be called influence line for MA. One more time, you're fixed on the right side, nothing will be changed. We have YA and we have moment. Your moment would like to make this member to smile. We have MA like this. Push your support up by 1. If you push this fixed up by 1, the whole beam will move up by 1. This shape can be called influence line for YA. To draw influence line for MA, rotate this fixed by theta equal 1. In which direction? The same direction like this moment. So I will rotate this fixed like this in the same direction, theta equal 1, in the same direction like MA. And the MA is assumed to make this member to smile. So the new shape of this beam will be perpendicular to this fixed after rotation. So this shape can be called influence line for MA. We have a new example here, simply supported beam called A, B, C, and D. We would like to draw influence line for reaction at A and B, and we would like to draw influence line for shear and moment at C. Okay, let's start with the influence line of reaction. First step. Actually, we have reaction here, YA, and we have reaction here, YB. If you would like to draw influence line for reaction, it's very simple. Push your support up by 1, any other support, keep it, and draw the new shape of the beam. So I will push, before this, I would like to assume these dimensions. This distance, 4 feet, 4 feet, 4 feet. Okay. Okay. Push your support up by 1. So I will push this support up by 1. Any other support as it is. So the new shape of this beam looks like this. One line. I'm wondering if you can calculate this value. How much? We have triangle similarity. The biggest triangle looks like this. The whole distance equal 12 feet. Then we have another triangle, this little one, with this value equal 1. And this distance equal 8. So this triangle looks like this triangle. We can make triangle similarity. So I can say this value, I don't know how much, divide this value, which is 1, equal the total distance, which is 12, divide this little distance, which is 8. So I can figure out this value will be 1.5. This value equal 1.5. And this diagram is positive. The whole diagram. One more time. If you would like to draw Confluence line for reaction YB, push your support B up by 1. Any other support as it is. The new shape of this beam, your beam must be one line because it's one unit. So the new shape of this beam looks like this. Can you tell me what is the value here? What's this value? I can do another triangle similarity. Between, we have triangle looks like this. This value is 1. This distance is 8. This little distance is 4. So I can say this triangle looks like this triangle. So I can figure out what is the value here will be 0.5. So this value will be 0.5. This shape is negative. This shape is positive. So the first part of this problem is done, which is Confluence line for reaction YA, Confluence line for reaction YB. Second part of this problem, we are looking to draw Confluence line for shear and moment at C. To do this, to draw Confluence line for anything else other than reaction, we need to play a game. What is the game? Actually, your trip on this bridge started from D until B. Perfect. The whole trip, the total trip on this bridge for your moving load, we have unit load is moving on the bridge, the whole trip from D to B. Actually, point C cut this trip to 2 parts. First part from D to C, second part or second trip from C to B. So I will assume my trip from D to C, first trip. From D to C, that means your unit load on this part of the bridge. I hate my unit load. I don't like to use it. I don't like to work with my unit load. So I will make my cut and work on the right part of the beam. Can you draw the free body diagram for this part CB? We have a part here. This part, I have my cut. I have reaction here, YB. At your cut, we have shear. This shear would like to rotate this member clockwise. So I will assume this shear to be up to rotate this member clockwise. V at C. And also I have a moment. This moment would like to make this member to smile. We have a moment. This moment would like, we have shear and we have moment. This moment at point C would like to make this member to smile. And remember this distance equal 4. One more time. First trip of your moving load will start from the beginning of the bridge until point C. You are playing, or your moving load is playing on this part of the bridge. So I will do my cut, and we have two options. You can work with the right part after your cut, or you can work with the left part after cutting. I recommend to use the part without moving load. Both of them works. Both of them will give you the same answer, but I don't like to work with my moving load. So I used the right part. Go ahead and draw free body diagram of the right part. And at your cut, we have shear and we have moment. And this distance equal 4. I can apply my equilibrium equation by saying summation f of y equals 0. So we have positive V at C. We have positive reaction YB equals 0. That means shear at C equal negative YB. This is the first equation. And also I can take moment, second equilibrium equation, I can take moment at C equals 0 and assume this direction is positive. If you take moment at C, I will cancel VC because I don't have distance, but we still have moment at C will be positive in the same direction of your assumption. And we have negative YB time distance 4, opposite your assumed direction, equals 0. Finally, I can say MC equal positive 4 YB. The second equation. Okay, so the first trip of your moving load from D to C is done. Let's start our second trip. Your second trip means your moving load is here. From C to B. So I will do my cut and I will work with the left part to draw my free body diagram. One more time. Your moving load is playing on this part of the bridge. I will do my cut. We have two options. Both of them works. You can work with the right part or work with the left part. Both of them work, but I don't like to work with my moving load. I hate it. So I will work with the left part. Can you draw the left part? Cut, and here is the left part. So the second trip from C to B, moving load from C to B, and I will use the left part. My cut. Here is your cut. Here is your reaction YA. At your cut, we have shear. Would like to rotate this member clockwise, so it will be down, V at C. We have moment. Would like to make this member to smile. MC. And remember, this distance is 4, and this distance is 4 feet. Go ahead and apply the equilibrium equation. So if you apply summation, f of y equals 0, we have positive YA, we have negative shear at C equals 0. That means shear at C equal YA. If you take moment at C equals 0, assume this direction is positive. Taking a moment at C will cancel shear, but you still have MC. And we have 4 times YA in opposite direction, so it's negative, equals 0. Finally, MC equal positive 4YA. So I'm done with my 2 trips. The first trip from D to C, the second trip from C to B. Let's go back to your diagram. We would like to draw confluence line for shear at C, confluence line for moment at C. Let's start. Where is C? Here is C. I recommend to draw a vertical line from C like this. Very important. Okay. Then go ahead and do some cut and paste. What you mean? I mean from D to C, what is the value of shear? Negative YB, based on your calculations. From D to C, where is YB? Go back to your diagram. Here is YB. From D to C, you are talking about this part of this diagram. I think this value will be 0.5. Maybe from triangle similarity. So get this diagram of YB and multiply it by negative. Multiply it by negative means this diagram will be the same shape but in opposite direction, like this. This value is positive 0.5 will be negative 0.5. This value is negative 0.5 will be positive 0.5. From D to C. What about the second trip? From C to B. From C to B, your shear equal YA without negative. So, from C to B, we are talking about YA in this area, from C to B. This value, I think it would be 0.5. Triangle similarity. Get this shape as it is without any change because we don't have any negative. It's positive YA. So without any change, put this triangle or this little triangle here. And this value will be 0.5. So the final shape of this diagram can be called confluence line for shear at C. The same sequence to draw confluence line for moment at C. Let's go back to the first trip. From D to C, your moment equal YB times 4. From D to C, here is the shape of YB. Can you multiply this shape of YB by 4? Remember, by positive 4. So don't change any. Keep it as it is. The only change is this value is positive 0.5 will remain positive, but this value will be 2. 2 because you multiplied 0.5 by 4. And this value is negative 0.5, will remain negative, but this value will be 2. First trip. Second trip, your value of moment equal YA times 4 from C to B. From C to B, here is YA. Can you multiply this triangle by 4? You can get another triangle here. This value is 2, positive. This shape is the influence line for moment at C. Let's do some review or sketch influence line of reaction for more complicated problem, more complicated beam, compound beam. If you have beam looks like this one, so we have reaction YA, we have reaction YC, and we have reaction YE. We are looking to draw influence line for reaction YA, influence line for reaction YC, influence line for reaction YE. Before starting, you have to remember, you have to keep in your mind that this beam consists of two parts. The first part, this one, this part is one unit, must be one line during your diagrams. And the other part, this one, is another unit, must be a line during diagrams. Let's start. If you would like to draw influence line for reaction YE, push your support E up by 1. Any other support, keep it as it is. So this one will be remain at the same position. This one will be remained at the same position. Can you draw the new shape of the beam? Yeah, I can. Remember, this part must be line, must be one unit. Okay, I know the location of this point and the location of this point will remain at the same location, so the new position of this member will be the same position. And also, at this location, we have something called pin connection. If the right side didn't move, the left side will not move. The final shape of this beam looks like this. This shape can be called influence line for reaction YE. One more time. If you would like to draw influence line for YC, push this support up by 1. Any other support as it is, without any movement. Keep in your mind that this part of the beam must be one unit, one line. So I believe the new position of this part will be like this. Keep in your mind that this connection, the right side of this connection moved up here. That means the left side must move up to follow the right side. So the new shape of this member looks like this. The influence line for YC. Influence line for YE, push support E up by 1. Any other support, no movement, no movement. What should I do? put in your mind that I'm still reminding you, this part of the beam is one unit, must be one line, one straight line. So the new shape of this beam looks like this. One line. And at this connection, the right side moved down, the left side will move down. So the new shape of this part will be like this. This shape, negative, positive, negative, can be called confluence line for YE. Remember, this shape is negative. Okay. One more example. We are looking to draw confluence line for YA. Remember, this support is fixed. We have MA, and this one is rollers. We have reaction YC. We are looking to draw confluence line for YA, confluence line for MA, confluence line for YC. I would like to remind you for something. You have fixed it. And I would like to draw confluence line for reaction and confluence line for moment. Your moment is assumed to make your member to smile. Okay. If you push this part, this support up by one, this beam or this part of the beam which is attached to this fixed will move up. If you rotated this fixed the same direction of the moment, like this with theta equal 1, the new shape of this beam will be like this. Keep in mind these two situations. So we have this part only is supported by this fixed. And we have another part is one unit. And in between, we have here something called pin connection. So if you would like to draw confluence line for YA, push support A up by 1. If any other support, as it is, no movement. Remember, if you push this fixed up by 1, this part of the beam will move up. This part only will move up. So the left side of this connection moved up with this member. The right side will move up, will follow, cannot leave each other. So the new shape of this part of the beam will be like this. This one will be negative and this one will be positive. Confluence line for moment at A. Rotate this fixed support by theta equal 1 in the same direction of the moment. So the new shape of this part of beam, which is attached to this fixed, will be like this. And any other support, no movement. The left side of this connection moved down. The right side must move down with the same value. The new shape of this part will be like this. Positive and negative. Confluence line for YC. Push support C up by 1. No movement at any other support. Keep in mind, if you have fixed support and you didn't move this fixed, that means this member will not move any. So I didn't move this fixed. So this member will not move any. If this member didn't move, that means the left side of this connection didn't move, the right side will not move. So I know the location of this point, the location of this point. So the new shape of this member will be like this. Positive. This shape can be called Confluence line for YC. More complicated one. We have fixed, so we have reaction YA, we have moment MA, we have reaction YE, and we have reaction YD. We are looking for confluence line of YA, confluence line for MA, confluence line for YE, confluence line for YD. Push your support up by 1. I would like to remind you that this part supported by this fixed. We have another part, and we have a third part. Each part must be straight line during your diagram. So I pushed my fixed up by 1. This part of the beam will move up. The fixed. This left side moved up. The right side will move up. I forget, if you pushed your fixed up by 1, this support will remain as it is, and this one will remain as it is. The new location or the new position of this part of the beam will be like this. The left side at this connection moved down, the right side will move down, so the new location of this part of the beam will be like this, positive and negative. Rotate this fixed by angle theta, if theta equal 1 in the same direction of the moment. The new shape of this part of the beam will be like this. This connection moved down, and no movement here, no movement here. And keep in your mind, we have, this one is one part, we have another part. So this part will be like this. This connection moved up, so the new shape of this part will be like this, positive and negative. Push support E up by 1. Any other support, no movement, and no movement. Remember, we have 3 parts, this part, this part, and this part. If you didn't move this fixed, this part will not move. That means this connection didn't move. That means the new position of the middle part will be like this. This connection moved up. So the new position of this part will be like this. Positive. Push support for confluence line at D. Push support D up by 1. No movement here and no movement here. We have 3 parts of the beam, this part, and this part, and this part. If you didn't move the fixed support, this part will not move. That means this connection didn't move. And you already didn't move this point. So the new location of this part will be the same. So this connection didn't move, the new position of this part will be like this. One more example. We are looking to draw confluence line for reactions at A and C. And what is the confluence line for shear at D? Okay, let's start with confluence line for reaction. We have reaction YA and we have reaction YC and we have reaction MC because it's fixed. So push support A up by 1, but before pushing anything up, you have to figure out how many parts do you have. Actually, we have this part and we have another part supported by this fixed. In between, at this location, we have something called pin connection. So let's go back to confluence line of YA. Push support A up by 1. Any other support, no movement. And keep in your mind, fixed support is a special fixed. If you didn't move this fixed, the attached part will not move. If this part of the beam didn't move, this connection didn't move. So the new position of this part would be like this. Okay. Confluence line for YC, push support C up by 1. Any other support, no movement. Keep in mind, we have two parts. This part, which is attached to the fixed, and this part. If you push fixed support up by 1, the whole part, this part, which is attached to the fixed, will move up by 1. That means this connection moved up by 1. That means the new position of this part will be like this. Confluence line for moment at C, rotate this fixed in the same direction like this moment by angle theta equal 1. And keep in your mind that this part, which is supported by fixed, will be like this. So this and this support will not move. This connection moved down, so the new position of this part of the beam will be like this. I am done with confluence line of reaction. We have reaction YA, we have reaction YC, we have reaction moment at C. The second part of this problem, we are looking to draw confluence line for shear at D. Let's play our game. Actually, the whole trip for this moving load from the first point on the bridge to the last point of the bridge from A to C. But point D cut this trip to two parts. So the first part of your trip from A to D, that means you're moving load probably at any of these locations from A to D. I will do my cut and I hit my unit load. So I will use the right part. What is the free body diagram? Your free body diagram looks like this. Here is the cut. At this location, we have reaction YC. At this location, we have moment MC. And also, at your cut, we have shear. Would like to rotate this member clockwise, so I will assume it like this. This point is D, so this shear will be VD. And we have moment, would like to make this member to smile, MT. Go ahead and apply the equilibrium equation by applying summation F of Y equals 0 we have positive VD, we have positive YC equals 0. That means V at D, shear at D equal negative YC. Take moment at point D. Actually, we don't care about moment. We are looking for shear only, so I don't care about moment. Second trip. Your second trip, your unit load is moving at this location or this location from D to C. From D to C. Then I will do my cut and I will work with the left part. Your left part free body diagram, something looks like this. There is a cut at this location. We have pin connection. I don't care. We have reaction here YA. At your cut, we have shear will be assumed down to rotate clockwise. V at D, this point is D, and we have moment MD. We don't care about moment because moment is not required. We are looking only for shear at D. So if you apply summation F of Y equals 0, we have positive YA, we have negative V at D equals 0. That means shear at D equal positive YA. Finally, we are looking to draw confluence line for shear at D. Can be written QD or confluence line for shear at D. Both of them works. So I recommend to draw a vertical line from D down like this and start to make cut and paste. First trip from A to D, we are looking for YC negative. From A to D, from A to D. Where is YA? Where is YC? I'm sorry. YC in this location, you are talking about this one. One more time, from A to D, from A to D, here is YC, this part, this diagram. Can you multiply this diagram by negative and put it here? Yeah. So this diagram will be multiplied by negative, so it will be like this. This value is 1 positive, will be 1 negative. This value is 1 positive, will be 1 negative. Here is the diagram. Second trip, from D to C, your value of shear equal YA. Your value equal YA positive from D to C. Where is D to C? From D to C. Do you have any diagram for YA? Do you have any diagram here? No. So get this diagram if you have, multiply it by positive and put it here. This shape is the confluence line for shear at